So this is a 4.2 application problem. Basically what's going on here is we've got a guy, so let's just say Robert buys 300 feet of fence, okay? And so Robert's got a creek in the back of his property, and he wants to build a rectangular fence along the edge of the creek, and so one side of the creek is going to border this little rectangular field that he's making, okay? Now, I want to know, how do I maximize the area given that we've got 300 feet to work with? That's the question, okay? What dimensions do we need, okay, length by width, to maximize our area? So how do we find area? Area is equal to base times height, okay? So the base times the height for a rectangle, so my base times the height here. Now, I know that there's 300 feet total, okay? So if I was just going to ballpark this thing, all right, I don't really know how long this side is, but things that I don't know, I can just call x. So if this side here is x, what do we know about the side opposite? It's also got to be x, okay? Now, say that x was like 50 feet. Well, I'm just making something up. So say like I used 50 feet for this side here. Well, if I use 50 feet over here, then I'd have to use 50 feet over there. Well, if I use that 50 feet here and 50 feet there, how much have I used? Well, I've used 50 plus 50, I've used 100 feet. Now, what does that mean I have left to use for this last side here? Well, I literally used 100 and I had 300 to start with, so I take 300 and I minus the 100 to get the 200. So I'm going to do the same thing here with x, but instead of 50, I put x. So it's literally 300 minus, well, I use this side x here, and I use this side x here. So what does that equal to? That's 300 minus 2x. That's how long this side is right here, okay? Now, if you had a problem where it was, you didn't have the creek bordering here, maybe it was solid, now you'd have to split this up into two pieces. So you'd take that 300 divided and minus 2x divided by 2 and get the 150 minus x for each piece, top and bottom. But that's not what's going on here. We've only got one side since it borders a creek. So how do I find area? It's the base times the height. So I've got 300 minus 2x times x, the length times width there. Now, my area function, if I distribute this out, what do I get? I get 300x minus 2x squared. Okay? Now, you can do this a couple ways, but one way that's not too bad is using the vertex formula. Negative b over 2a, comma f of negative b over 2a. Now, what is a and b? So a, x squared plus bx plus c. That's kind of what's going on here. A is the coefficient in front of the squared term. B is the coefficient in front of the x term. So b for this problem, b is 300 and a is negative 2. So I'm literally going to take my value and I'm going to plug it in negative and then 300 over 2 times negative 2. Now, negative and a negative make a positive, and 300 divided by 4 is going to be 75. So what does that tell me? It tells me that this length right here, that's 75 feet. If this is 75 feet, this is 75 feet. Well, how much is this piece up here? I literally take everywhere I see an x, I replace it with 75. So 300 minus 2 times 75, so that's 150. This is equal to 150 feet. All right. So my dimensions that Robert needs to make The fence, in order to maximize area, is 75 feet by 150 feet.